Alright, so it's sometime later and the weather is somewhat quite a bit hotter, and I've got two new capacitors for this thing in this bag here from DigiKey. I was initially going to order from Element 14 or Farnell, as they used to be and still kind of are called, but they've been having some annoyances regarding stock levels and things, and sometimes you'll order something that says it's in stock and it'll take a month because they'll suddenly realize it wasn't in stock, or you'll order something that you think has like a 2-month wait time and then suddenly you get it next week, and I don't know, everything's kind of a mess with that a lot at the moment, it seems. So yeah, I ended up getting these from DigiKey. These are the same ones that I would have ordered from Farnell anyway, along with some other stuff that I was also going to order anyway. Just cost me a little bit more from there, but hey, at least I knew I was going to get this stuff in a decent time frame, which is what happened, so that's great. Anyway, these are the ones I got. I found it hard to get exact replacements in terms of the specifications for ripple current anyway, and size. The original one, like this one here, as you remember, it's a Zunder 6800 microfarad 50 volts HP series. There is a data sheet, you can look that up, and it specifies like a ripple current of, I don't know, 3.8 amps at 100 hertz or something. The best I could do with these, which are from Epcos, and these were like 3.6 amps. And this is a funny thing I've noticed with some of these Chinese capacitors. They often have ripple current ratings or ESR ratings that are just always somehow better than any other brand, but somehow they often seem to fail much faster. So I don't know if the ratings are just exaggerated or what, but I don't know. Hard to tell exactly. And without doing some calculations on the circuit to try to figure out what the actual current rating should be, I actually suspect that even these are possibly under-spec'd, possibly undersized, at least capacitance-wise. I would have liked to increase the value to maybe 10,000, but there's just not enough room on the board. Not really so much to do with the height, I think. In fact, the replacements I got are slightly higher than these ones by about 5mm, which I think should be fine. But the diameter is limited to 25mm or whatever it was, because these are right next to each other on the board. They sit right next to each other, and yeah, you just can't physically fit a wider cap in there. Even though the board is big enough, they could have fit larger ones on there. They just didn't design it that way, so you're stuck with putting like smaller values in than otherwise should probably be in there. It's overall, the more I look at these things, the more I research online about it, I think this is not actually a great quality speaker. Certainly some of the design choices don't seem to be particularly sensible. So anyway, so it's really the best I can do is to get what I got. Everything else that was available in the same size and everything had lower ratings, so I figured, the ones I could get, these ones here were the best that I could find, and hopefully they're good enough. Not really anything you can do aside from possibly modify the thing, mount the capacitors sideways or something. I don't know, bolt them to the heat sinks and then run big wires to the PCB or something. I don't even know, if there's other faults with it, so no point going to that sort of route when you're just trying to find out if the thing actually works. A kind of idea that might be good for a modification when you know the system is working, but yeah, as it stands, troubleshooting, you want to just fix everything, put everything back to how it was first, and then improve it later once it's actually working, if you so desire. Anyway, so these are the ones here. They came individually in little bags, which is nice. And as you can see there, EPCOS 6800 microfarad, 50 volts, same thing as the others, but slightly taller. You can see they are slightly higher. Again, I don't think that will cause an issue. The diameter is the same, which seems to matter more in this case. The leg spacing is the same, 10 millimeters. So you also have to worry about. Especially on a board like that with plated through holes where you can't really modify it. If it's a single-sided board, sometimes you can, depending on where the traces go, you may be able to drill extra holes, fit a larger cap in, move it around, etc., etc. For example, and again, you could potentially do that with a larger diameter one. You could move the mounting holes so they were further apart, then you could use a bigger one, but on a dual layer board, when you don't have the PCB layout, you don't have the board view, you don't know where the traces go, a modification like that is not easily done. So I just went with these because they are the same diameter. Anyway, I do wonder if vibration was an issue in the failure of the original part. And I don't really like the way they mounted the original just with some cheap glue. I mean, there are other ways of mounting capacitors. You can get these like brackets here. Now this is more of a chassis mount sort of thing. I mean, it has these solder lugs rather than PCB mount pins like these. So this is not really designed to mount to a PCB. It's designed to mount to like a chassis, like say in a valve amplifier or a similar thing, whatever. More sort of industrial sort of application as well. But yeah, I mean, they could have used something like this. Of course, that would have cost extra money, and I'm pretty sure these guys were trying to save as much money as they could when they built this thing. So yeah, obviously they didn't. They just used this this cheap glue here, this brown stuff, which is not particularly great. This does look very much like the stuff that tends to go conductive over time, can soak up moisture, it can go sort of corrosive, it's darkens. You can see over here it's sort of darker there where it had more heat trapped under the cap other than up the side where it stayed kind of light brown. Yeah, it's not very good glue. Removing it is a pain. Solvents don't really work. You can sort of just pull it off, scrape it off, but even that doesn't work that great. I found the best way to get rid of this is usually to heat it up slightly with a hot air gun on the lowest power, low temperature, and then it'll soften up to the point where you can pull it off more easily, but it's still quite a pain to get rid of, and it's not something you really want in your electronics because it's, like I said, it's great at causing corrosion and electrical leakage and short circuits and issues, and there are plenty of devices, namely televisions, I think, and other things with high voltage that have failed and blown up because of this glue going conductive and causing leakage between things that shouldn't have it. So yeah, it's all around not a great thing to have. But enough of that stuff to be going on with. It's time to put these in, and I shall do that. Obviously that's pretty simple. Put them into the PCB, solder them on. Nothing really amazing about that. Obviously you do have to make sure the holes are cleared so that the pins can go through easily. I already did that last time. Solder wick seemed to get that out fine. And then it's just a case of testing it out. Of course, these do need some kind of vibration, I say vibration dampening, but they need some sort of way to stop the solder joints from taking all the strain, because I mean this is a amplifier that can play pretty loud. It'll make a lot of vibration in the cabinet because of the large speakers directly there. These things will see some vibration, of course, under normal operation. And so they do need some kind of mounting. A lot of times with certain things you can get away with it just pull the glue off and who cares, but with this definitely it will need some kind of structural support, so I'll probably put some hot glue, I think, underneath these, maybe around the edge and up the sides a little bit once I have them soldered in. Maybe not the idealist thing, but again, I don't really have anything else. Silicone is probably the best, but you need the neutral cure type. The common sort of builder's grade silicone can often outgas sort of acidic compounds when it dries, and that's no good around electronics because of all the metal parts. You don't want the leads corroding away because you glued it on with the wrong type of glue. And that's the same thing, we come back to the same issue with this stuff, as it goes conductive and corrosive over time, and again, it's not a good thing, so you don't want that at all. Electronics grade silicone is obviously probably one of the best options, but hot glue is also used quite commonly, and is obviously easier to get, although again I would stay away from like the no-name brands of glue, because they could also have the same issue. I don't know, I haven't heard of that, but certainly cheaper stuff is not usually as good quality. Sometimes it has compromised things, could be contaminated, who knows. So if you are using hot glue, I would suggest using a decent brand of it. Alright, so here's the board flipped over again with the capacitors still removed. There was a little bit of glue around on this one, more than this one. Yeah, I just scraped it off with my fingernail actually. There's most of it there. There wasn't a lot. Most of it actually came off on the capacitors when I desoldered them. I suspect that when I heated the board to desolder them, the heated glue on the board let go more easily, and most of it just stuck to the capacitors. So I've scraped that off fairly well. There's minor residue, but it's not going to do anything. It's on top of the silk screen and everything, so no big deal. What I'll probably do is put a little bit of hot glue around the edges there, put the new cap on, wait for the glue to dry, then solder it in. Just do a test to make sure these actually fit. And yeah, they snap in just perfectly fine. They clip in, they're not going anywhere, but obviously you still want that glue or something to hold them in a little bit. Yeah, shows that I've cleared out the holes correctly. And again, like I said, these are unfortunately very close to each other. There's a slight gap there. I suppose you could increase the diameter by maybe 1 or 2 millimeters, but of course the next size up is 30. I think these are either these are 20 or 25, and the next size up would either be 25 or 30, and it'd be too big once you factor into the size of both of them that it wouldn't fit. There's also some other components and like the fuses and stuff around the side there that would be an issue. So yeah, in this case it's sort of increasing the diameter is basically impossible. You can obviously increase the height a little bit, which I've done because that's all I could really do, and there was enough space here. The back of the tweeter cone is up the top there, which is comes to somewhere around this area at the top. So these will stick down into the foam probably about here somewhere, in which case there is quite a decent amount of thing in there. So these being about 5 or 7 millimeters higher than the old ones shouldn't be an issue, I don't believe. Famous last words, but I'm pretty sure it's fine. Anyway, but yeah, so all that's left now is just to put some glue underneath and then solder them in. And again, for doing that I'll be using this soldering iron here because it's easier to plug in down there. It's also pretty powerful, and my other one, my benchtop one, obviously is too, but I can't reach all the way down here on the floor, and I can't lift this thing up on the bench because it's so heavy. I think it would either break the bench or destroy my spine. which I have already done once in the past and really don't wish to repeat. Alright, let's see if I can do this on camera and not stuff it up. This will be amusing. Yeah, I'll just take this cap, put a little bead of hot glue around the bottom there, I think, keeping away from the pins as much as I can, and then stick it on the board as fast as I can before the glue sets. That's the plan anyway. Hopefully it'll work. Alright, that seemed to be fine. Now it's all stringy like mozzarella. Right, let's do the other one. Obviously you really want to make sure you get them around the right way before you do this. So the negative faces that way. They both face that way, the negative. It's marked on the board too. There's a positive sign there and a white stripe on the half of the circle to denote the negative. So just make sure you get that correct, because otherwise these will blow up. You give them 40 volts reverse voltage, they will explode, especially from a big toroidal transformer like that that can dump a ton of current into them. Yeah, it's not pretty. Right, that seems to work. Let me get this stringy glue off my fingers. Yeah. Anyway, I was going to say, I wonder if I can put some up here in the sides, maybe between the two of them. I think that's probably possible. I might give that a try. I might need to turn the thing over and do that, like put it sideways. Maybe I'll wait to do that once they're all soldered in and everything's bolted back together, and I can turn the thing sideways without fear of the heat sinks falling off and ripping everything off the board. That's probably a good idea. So we'll just put that like that for now. And now I can solder them in. Alright, so I've got the capacitors mounted on the board again with the glue. Now it's time to solder them in. I also might resolder all the connections on the amp chips just in case. With all the moving around and stuff, it's possible they might have got cracked. Probably not, they look fine, but just in case I'll do it anyway. But right now, yeah, let's solder in these capacitors, and that should be fine. So yeah, nothing really to say about that, just a decently powerful iron and some good solder is basically all you really need. And I'm not entirely certain why I'm showing this, because it's not that interesting, but hey, it's only 4 joints, so it's not going to take much time. Anyway, make sure you apply enough heat and enough solder to flow all the way through the through hole. Again, these parts do see high currents because they're feeding the rest of the circuit and everything, so you don't want the solder joints hanging on by just a little bit on one side of the board. You want to get the solder all the way through the through hole to make sure that it does actually work, get good contact, and you know, and everything. So I'll just make sure of that. And yeah, nothing particularly interesting about that. Just soldering the parts in. So I've done one. I'll do the other, and I'll reflow the joints for the amp ICs off camera. And then we can put it back again and give it a test and see what happens. Alright, so I've soldered in the capacitors, I've reflowed the joints on the amp ICs. I don't think I needed to, but I did anyway. And now I'm just doing the heatsink paste again. Notice there are some sort of voids there, like on the original pattern you can see a big sort of void there, and there's some sort of up here and kind of one there. It's not perfect, but it's probably good enough. But what I did is I took my screwdriver here. I haven't actually, I mean, normally you'd clean everything off and you'd repaste it and everything, but I'm feeling a bit lazy today, so I didn't bother. And also we don't even know if this thing works perfectly anyway. It might be that I have to take it apart again at some point. Who knows? But I found there was some like spillover over application. I was going to say overspray, but that doesn't make sense. But there was some heatsink paste around the edges of these like cutouts here that I was able to scrape off and sort of paste over the top of this one to get a repaste the layer on this one. I don't have enough to do that side, but obviously you don't want too much, because too much the paste will start acting like an insulator instead of a conductor, and then you actually have worse thermal performance than without it. Well, not worse than without it, but you know, not as good as with the minimal appropriate amount. Anyway, I could add some more thermal paste to this side, but I think what I'd rather do is clean up, maybe scrape off and clean off these underside bits and put it on, try and transfer onto here. So I'm going to use this old gift card thing, use a credit card, whatever, same kind of thing, just doing these plastic cards, and hopefully I can scrape this off here and then put it on there and sort of redo a thing on it, so that it'll reapply itself. If you just put it back on exactly as it was, then you end up with voids and stuff where you pulled it off, and the thermal transfer may not be as good as it was in the original application. So it is better to redo it if you can. So I'm just going to try scraping that with this. Should pick up a little bit. I mean, this stuff is still like nice and soft and pasty, so it makes sense to reuse it. But yeah, I'm not getting a lot off there, so there's some. I don't know. You can see a little bit has come off. I may be able to use this on here, but I may have to just add some more, possibly. We'll see. Anyway, that's something you can do. But it's not the ideal thing. I think I will at least clean this surface with alcohol is probably the best way. Wipe it off with a rag or something, tissue, whatever, and then clean it with 99% isopropyl alcohol to clean off the residue. Alright, so I've cleaned this back part off, I've redone these. Looks alright to me, and now it's time to bolt these back on. So this back plate thing needs to go onto there, and then we can put that on here. So because of the way this is sitting, the heat sinks don't perfectly line up with the hole, so I'll do one side first. I'll put the screws on one side first, then I'll lift this a little bit to get the other side in, and then once everything's lined up I can tighten it all down. So I'll just put these in here, 3 on that side, and I'll tighten it a little bit. Just wipe this paste off my finger so it doesn't go everywhere. I don't want it perfectly tight just right this second, but there we go. And then grab one of these and just gently lift this a little bit so the heatsink moves into place. Of course I get a ton of paste all over my finger, thanks to these screws being covered in paste from going through the heatsink that's covered in paste. Put that one in, this one, I need to lift that at the same time as well. From this end and put that one in. Let's see. It's not going in properly. There we go. It's working. And the last one in the middle over here. And again with these things, sometimes you have to back the screw off a little bit to get it to center in the thread correctly before you screw it in fully. Help get everything in. And there we go. Now I can do these up nice and tight. So we've got a good thermal interface between the back and the heat sinks. Again, not sure that really does a huge amount. This would dissipate a little bit of heat, but I don't know how much. Ideally you'd want a heatsink sticking out the back here. And it's actually interesting, they talk about the design of this in the advertising material about how the airflow of the speakers is supposed to flow across the heatsink fins and cool it down, but I don't really understand how that's supposed to work, because A, you've got this big damping mat in the middle, speaker stuff, I can't remember the term for it right now, but that's in there, that's going to block a lot of airflow, and then there's no real place for the airflow to go once it goes over the heatsink fins anyway, so yeah, I'm not sure that really makes that much sense. I mean, there will be some air movement, I suppose, across the fins due to the speakers moving, but I don't know if it's as much as they claim it would be, and certainly not as much as having a fan blowing straight across them. And yeah, I mean, for best cooling you'd want to have fins sticking out the back and into free air, but anyway, I don't know. Like I said, it's a weird design. I'm not sure if the people who made it were really bothering that much about quality, to be honest. I think it was more just trying to get something down to a price point, considering what I've read about the reliability of these things in general. But anyway, yeah, so this all seems to be alright. I'll just tighten these screws fully and then we can give it a test. Alright, that's a take two on that segment. I was just plugging it in and wondering why nothing happened. It was because I forgot to put the fuses back in the board. So let's try it with the fuses actually put in the board, and then we'll plug it in and see if it works. So I've got my multimeter here on the rail, the negative rail. That's the one that was working before. And so if I plug that in, we want to make sure that still works. So I've got that all hooked up, and just in case it explodes, I've got my safety glasses on, but I don't think it will. I don't see why it would. I've literally only changed these caps and that's about it. So, and they are around the right way and everything, so I shouldn't have an issue. But here we go. Let's power it up with the fuses in, so the circuit is actually powered, and we'll see what happens. And we get negative 38 volts on the negative rail, which is, I believe that's what we want. Something like that, negative 38. Sounds about right. Let's unplug that. It drops away fairly fast, but not instantly like the positive rail was doing when it was faulty. And now let's see if we test the positive rail, which we should have the same behavior. So this one gave us what, negative 38, so on the positive we should get positive 38. Let me just check the exact voltage of that, plug it back in again. Negative 38.35. Okay, so we should get very close to that on the positive if everything makes sense. Positive 38.35 is what we'd expect. Now I just figure out which of the diodes to hook my probe to. So I want to connect to the cathodes of D7 or D5. Okay, that's these two down here. That should be there, and we do see we actually get a positive voltage on there. So that positive rail cap is still a little charged, which makes sense. And if we plug this back in, we do get our 38.39, so very close to the other, which was 38.35. That's pretty much what I'd expect. So yeah, the voltages are the same on the positive and negative rails, well, except the fact that one's negative and one's positive, but the actual value is basically the same, which is obviously what it wasn't before, but now it seems to be fine. And now if I unplug it, we see the positive rail also drops down slower than instant. So obviously it all makes sense. The capacitors are fine, which we know because they're brand new. And that is what you'd expect, so I would say it's fixed, or at least the voltage issue is fixed. Now of course the question is the actual audio fixed? Has the buzzing noise gone away? That is the other question, and that is a question which I can say right now does seem to have gone, because I did not hear anything when I plugged it in. I didn't even hear a pop of the speakers when I switched it on, and they are plugged in, they are connected to the board, so unless all the amplifier chips have suddenly just died and gone open circuit, it looks like, well, it sounds like at least, that it's working as you'd expect. Without any input, it should be basically silent for a hi-fi amp chip like the ones used here. They're pretty good quality. They shouldn't make any buzzing noises at idle. Alright, so I've bolted the rear panel back on with half the screws. I'm going to take it apart again so that I can put some more hot glue around the caps and also on the speaker and mains connectors. I mean the transformer output connector, because they were glued on before, and again this is a thing that makes vibration, so it is a thing you kind of need to have. Yeah, powered on right now, and I hear no buzzing at all. If I stick my ear up right in here by the tweeter, all I can hear is a background hiss, just a faint hiss. Background hiss you'd hear out of an amplifier. There's no buzz at all, so that sounds like a good sign. And I'll try doing a comparison test. If I get my microphone up near the thing and I touch the input jack, when I take my finger off, you hear absolutely nothing. And that's that. The background buzz that was there normally without doing anything has gone. And now this thing seems to be working fine, at least at idle it is. I haven't put an input signal in obviously, but it seems to be okay, and yeah, which is great. So that looks like that's what it was, just that capacitor was open circuit, huge amount of ripple on the positive rail, and kind of surprised these amplifier chips could handle it that well, that the buzzing noise coming out was such a low level. It was more of an annoyance really than sounding like an actual fault. And yeah, it could still play music and everything. Will be interesting to see if it sounds better. It probably will. I mean, it sounded alright before, but I'm assuming the audio quality will improve now that it has proper rail voltage. The power supply is now actually functional. But yeah, I'll take it apart again. I'll hot glue those connectors. And then I'll put it back together properly, and I'll give it a test. I'll play music on it and run it for a few hours, I guess, or whatever, and verify that it's fine. It doesn't have any other sort of issues. But as far as I can tell, that was the only problem. Like I said, the person that was selling it, the shop that was selling it, just said it was faulty and didn't work. I don't know if that meant the buzzing noise, or possibly because of that maybe the amplifiers would overheat and go into shutdown mode if you actually tried to use it for any period of time. I'm not certain, but yeah, hopefully it's fixed. I didn't see anything else wrong with it. I'm pretty sure it was just that capacitor, which I still have over here. I put it in a plastic bag because it was making a horrible smell. But yeah, looks like that was it. Just that cap was bad. So there we go. I might run this for a while, give it a good test out, and then I'll come back with the final verdict. Does the thing work after a decent amount of playtime? And yeah, then I'll conclude the video and we'll see what the answer is. But I would say it's probably fine. It's just a shame that these things are apparently not super high quality, and they're also really, really heavy. So, well, not really heavy. I think it's about 30 kilos, but it is a bit on the heavy side compared to other models, apparently, from other brands. Oh yeah, something else I forgot to mention, which I also noticed. It makes sense. Turn it on, turn it off, turn it back on, turn it off, turn it back on, turn it off. No clicks, no pops, no big thumps. So yeah, I guess that rail imbalance and issue was also causing that power on thump. If you switched it off and then switched it back on immediately, you'd often get a big thump through the speaker, and that seems to be fixed as well. So yeah, interesting symptom. Low level buzz, but a horrible thump occasionally if you turned it on without waiting for the caps to discharge. But now, since both caps are working, that problem seems to have gone away. Alright, I've just got my phone plugged into it. The battery is really down, so I don't know if it's going to work for very long, so I'll just quickly do this. But yeah, you can probably hear it. Let's see. Definitely works. Yeah. Sorry, my volume button on my phone is a bit munted. But yeah, it seems to be working. Just turn it down a bit. I can't tell any difference in audio quality. To me it sounds about the same as it did before, but yeah, it certainly works. There's no buzzing in the background, and yeah, so it definitely is still going. This is supposed to be royalty free, so hopefully it is. But anyway, yeah, enough of that. There'll be enough time for that to do that while testing it. Just one thing to note, I suppose, with this, when you do put it in here, the screws for the back panel, they're kind of hard to thread on because of the weight of this pulling it down, but also because the threads are not perpendicular to the back plate, I don't think, or I think they're kind of like what's the angle they're on? yeah, they kind of stick out on a different angle than what you'd expect, so they're a bit confusing to put in initially, but it does make sense once you get it in. But anyway, that's just one thing to note. Alright, so it's been a few days. I've given this thing a pretty decent test, I'd say, and it seems to be working fine, so that's good. I kind of expected that. Yeah, so it's nice. Didn't notice any issues with it at all. I was going to say there are these large base ports or whatever they are up the sides here. I didn't really realise, but yeah, they move a lot of air actually if you turn it up pretty loud. So yeah, I guess the cooling system that I was wondering about for the heatsink and everything, it probably does work quite well, because this thing, yeah, there is a lot of air movement out of these vents and whatever, and through the cabinet, I suppose. So maybe it does work. I don't know. It still seems a bit odd with all that, dampening foam sheet like between the heatsink and the speakers. But I mean, yeah, there just definitely seems to be a lot of air movement in there at high volume. So I guess it does work anyway. So that's cool. Because yeah, like if you turn this thing up pretty high, and it does vibrate a lot. I mean, the back vibrates everything. So I actually do think it's quite possible that original capacitor, this one here, the dead one, could have just failed from the vibration in the environment. I mean, it does get a lot in there if it's playing at a high sound level. I don't know how loud it actually gets. I don't have like a decibel meter or anything to actually test that, but it certainly gets pretty loud. I turned it up, test it for a bit at like really high volume, and it yeah, it outputs a lot of power. Shouldn't really be surprising. I mean, it does have, about, I calculated 270 watts or something. Well, maybe. I forget the exact number. Anyway, but yeah, it's pretty powerful, which is not surprising. But I guess I'll try and get it out of here because I don't really need it. It's too big and heavy for what I need. This sort of thing, I want something more portable. It's not really suitable for me. I would love to keep it because it is pretty nice and it does get a good amount of power out of it. Just unfortunately, it's just too big and heavy for me to keep, really. So hopefully someone else will be able to enjoy it. And hopefully those capacitors will last. I have put a decent amount of glue between them and around them, so it should hold them in place. Hopefully, see if it comes back again with the capacitors falling off it. If it does, then I'll know to use something else. But yeah, anyway, it seems alright, I think. I mean, it's strange, like I said, that this one here is still fine. It still tests fine. It still seems fine. It doesn't rattle at all like the other dead one. But yeah, I don't know if the vibration from just the thing running damaged that other cap, or if that other cap was already damaged, like it had a weak spot from the manufacturing, and the vibration just finished it off, or what. I mean, that makes more sense, I guess. It was probably just like defective manufacture, and it just failed due to the environment that it was in. So yeah, hopefully that was interesting. Hopefully that was a useful video. If any of you have one of these yourselves and you have similar problems, it might be worth checking to see if the capacitors haven't died internally. I'm kind of surprised that happened. I've never seen that before. All the caps I've replaced so far have just been ones that have failed due to overheating or whatever. I've never seen one go short circuit. I mean, open circuit like that internally and just have the contact break off entirely. I've never seen that before, so I suppose it's certainly not uncommon. I'm sure there are more capacitors that have failed that way. It's probably not the only one in the world, but yeah, and certainly first for me. But there you go. It's dead, it's replaced, it works now. Still kind of disappointed that it wasn't a fake cap though. That would have been really funny. I would have liked to have seen that. Always amuses me the way some things can be, but there we go. Yeah, that's it. I've probably said more than enough, and yeah, I guess I'll see you next time.